Good evening guys. Welcome back again to my channel. Musta na mga katono? Dito na naman tayo. Today we are having a Sound Magus monoblock amplifier. The model is X6500 Class D amplifier. I believe this is a dual channel amplifier rated at 3250 per channel, and when connected bridge connected, it will produce 6500 watts RMS. The owner told me that suddenly it went on protect mode. They were using it, actually they used it in the competition, and then after some time after the competition, they told me that when they tried to turn it on after, then the protect mode came on. So let's start. Let us see what we can do. Tingnan natin kung anong sira nito. At sige, umpisa na natin. So let's start removing the cover. Yes, after removing the screws, you have to remove the plate on each side so you can lift this up and separate it from the bottom. And yes, as I have suspected, this is a dual amplifier. This is the this is the one amplifier, and this is the second one, because it's a two-channel amplifier with a separate power supply. So if you want to run both of it, you have to connect the the connectors together in parallel, and it has one remote line as well, and two channels, this one and the other one, this one. So I believe one channel is around 3250 each channel, because this one is rated 6500 at 1 ohm load. So yes, before doing something, let's just check, make an ocular inspection if there is anything suspicious here. As I see, I think it's well and good. I do not see any traces of burn or any parts. You know, this Sound Magus they are fond of using this resin glues on the capacitors and on their drive boards. If you can see, because after some time this resin glue will turn uh, turn black, and eventually, after a long time of use, because of heat, these resins become conductive. But I hope not, because it's very annoying, in removing. It's difficult and annoying removing these resins. Sometimes in the process of removing it, you come to a point that you will damage some of the components or the traces of the board. But now I think it's well and good. Now, first thing, let's check because he told me that the problem here is it went on protect mode. So either there's a problem with the drive circuit, the drive board. I believe this is the one. Yes. Or there are shorts on the output FETs. Let me check. Now I set to continuity, or normally I do it on resistance mode. Good. Wow, so that's it. There's a short. Yes. Yes, there's a short on the gate and the drain of this. The next one. Yes, the other one also. Yes, these three, these four. But maybe one of these FETs are shorted. Let me go back to. Yes. Yeah, this is the one. Yep. Yep. This one's the shorted FET. Let me mark this one. And on the other bank, go to dive mode. Good. 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 The beep is coming. The beep is coming from the capacitors that is being discharged. Yes. Good. Yep. There's another one. Yes, there's another shorted FET. And this one. Let me mark it again. This is the one. So there are two FETs that are shorted. 1 and 2. Now what we do next is let me check let me check the other one. Let me check this one. Let me check this other amp. Any burned areas? It's well and good. Second diode mode. Good. Let me show you. One minute. Okay. Good. 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 And let's check the other bank. Yes. Oh. Is it shorted? Yes, it's shorted. Oh. No, I don't think so. This is not shorted. It's coming from... No. So what we can do now, but I believe this is not shorted. Okay, let me check something to make sure. Let me check first the any voltage, because this I did not find any pull down resistor on the power supply. So to make sure and for safety, we try to short one leg of the drain on the high side and source of the low side. Sorry, where is the low side? Yeah, this other one. Okay. Okay, now the other one. On the high side. And a low side. Just to make sure. Okay, all in done. Okay, let me check this other amp with the power supply, because I believe this is good. I connected already the power supply of this one, and we will see if it will turn on or it will give the protect mode the same. Let me check. Power on. That this one is good and not defective. I will show you the blue light. See, the blue light is on. Okay, so I believe the defective one is this amp. So what I will do is I will remove it from the board, from the case, and we will check it. We will go deeper on it and check it. Let me switch off. By the way, the power supply of these amps are separate. This is the supply terminal on this one, and this separate, and the other one has a separate power terminal as well. So I will just put it off. Now let me start removing the clamp of on each side first. One, two, three, four, five, six, seven, eight screws. Now, as you can see, I already took out the board from the body case, and I just removed the shorted FETs, one on this side and the other one on this side. But I found out as well that there are gate resistors that were defective, and they are already open. This one, let me check if you can see it. Yeah, this one and this one, two resistors that are 10 ohms each. I checked the diodes and they're all they're well and good. So now what will I do is I will remove all the pads, replace the 2 resistor, power up, and I will check if there is a drive signal on the gates of the low side. Okay, let's do it. Okay, now as you can see, I removed all the FETs here on this high side and all the FETs here on this low side of the bank. Now let us check. I've connected the power supply to around 10 volts. Let's power it up and we will see if there are drive signals on the low side and the high side, as well as the rail voltage. And we will see if we can check if the blue light is lighting with this other channel amplifier. Okay, let's power. I hope this goes good without a bang. Yes, there's a blue light. There it is. There's a blue light. Now, let me check if there's a drive signal. on the low side gate. Let's put my oscilloscope to 2 volts and 10 microsecond time division. Yes, there is a signal on the low side. Yep. Yes. Yeah. On the other one. Yes. Yes. Oh, there's no signal. Oh. Okay. There's no signal because the gate resistor is damaged. It's defective. Let me check the other end of the resistor. Turn on. There is signal. There is signal. Okay. So now, yes. Yep. There is. There is. And there is. So I believe only the patch is needed to be replaced, and I hope after replacing the MOSFETs, this amplifier will come alive, and I hope it would be repaired. So what I will do is I will put one FETs on each side and we'll see. So I fixed 2 MOSFETs on one other side and 2 MOSFETs on the other high and low side. One on each bank, one on the high side, one on the negative side, and this one on the high side, and on the negative side on the other bank. Now we will check now if there is switching on the output MOSFETs. Let me put on my power supply to, let's take around 9.5 volts. Okay, and 10 microseconds, 5 volts on my oscilloscope. Let's power on and check there's a switching. Yes, there's a switching. All right, now I'm happy with this. Now let's check that is on the low side, one bank, and on the other bank low side, negative side, on the same on the drain of the MOSFET on the low side. Yes, there is switching. And on the high side gate, yes, there is switching. And on the other bank, yes. Okay, now since we have confirmed that there are switching on the outputs, I'll turn off the supply and let me check the temperature of each MOSFET on the output MOSFET. It seems normal to me. Yes, stone cold. Yep, stone cold. Yeah, temperature is normal. Let me check on the supply FETs. Yes, I think every one of them is normal. However, now I will fix back all the MOSFETs, 4 on each bank, and then we will see if we have fixed this amplifier. Okay, now all the FETs are fixed. On the positive side, 4 on each bank, and on the negative side, 4 on each bank. Now we will power it up and we will see if there is a switching. So that would be the moment of truth. Put on my power supply to 9.5. Okay, check on the low side, negative side, on the drain of the MOSFET. Power on. Yes, we have the switching. Other side, other bank, we have the switching. On the high side, switching, yes. Well and good. Oh. Yes. Okay. Now I'm happy with this. Let's turn it off and let me check the temperature of each FET, if they are happy or not. It seems they're all normal. Yep. Okay. Well and good. So I hope this will come alive, but we're not over yet. We will feed the signal and we'll check the output. We'll put a 50 Hertz sine wave and check the output if there is a clean signal of sine wave. Let me set up again my frequency generator and my RCA. Okay, everything set up. Frequency generator, 50 Hertz sine wave on the RCA input. Power supply, oscilloscope at 5 milliseconds and 2 volts. Let's power on. Let's confirm the switching. Yes, there is switching. There is. There is. There is. Okay. Let's feed the signal. Power on again. Yep, we have a signal, as you can see. That's well and good, and I hope we had repaired this amplifier. So what I'll do now is fix back to the case, clamp it down, put a new heatsink compound on each MOSFET. Then after fixing all together, I will feed the signal again at 50 Hz, check the gain, run a bench test, how much power it puts out, if it's putting out the same power as its specification, and then I will run an endurance test. If this all passed, then it will be ready to go. I think this is a straightforward repair. We had only a blown or shorted FETs, one on each bank of the high and the low side, and we have 2 blown resistors, gate resistors, and that's it. Yes, and we have repaired this, and I'm very happy. So if you have some questions, you can hit me up on the comments, and I will be glad and very happy to answer your questions. So that's it for now. Thank you again for watching my videos of repairs of this amplifier and others. So see you next time again on my next repairs, and I will be happy to give you some hints on repairing these kinds of amplifiers. Okay, that's it, my buddies, mga katono. Maraming salamat, and see you on my next video. Bye.